In this video, we will be going over a GCSE question regarding the surface area of a frustum. So, on the left we have our question. A frustum is made by removing a small square-based pyramid from a similar large square-based pyramid as shown in the diagram. The height of the small pyramid is 15 centimeters. The height of the large pyramid is 45 centimeters. The square base of the large pyramid has side length 39 centimeters. Work out the total surface area of the frustum. Give your answer correct to the nearest whole number. So, on the right, we have shaded in the frustum, and this is the surface area that we're going to calculate. So the first thing that we're going to do in our approach to this question is we're going to find the area of one of the triangular faces on the large pyramid. So this is one of the triangular faces, and so we're going to try and find the area of this. So the first thing that we're going to do is we're going to draw this triangle here, where there's a vertical line going through the middle of the pyramid. There's another line that goes through the middle of one of the triangular faces, and another line that goes across the base. And so on the right of that, we've shown the measurements for it. So the triangle that we shaded and drawn has a height of 45 centimeters and a base of 19.5 centimeters. The base length we have got is 19.5, as 39 over 2 is 19.5. And since it starts from the midpoint and goes to one of the sides, a nice straight line, it'll be exactly 39 over 2. And so this is a right angle triangle because the vertical line makes a right angle with the base. And so we can use Pythagoras to find the height of one of the triangular sides. So Pythagoras' theorem is a squared plus b squared equals c squared. And we're going to substitute our values in. So our c here is our hypotenuse that we're trying to find. So we have c squared is equal to, so let's take a as 45 centimeters. So we have 45 squared plus b, which is 19.5 centimeters squared. So c is equal to the square root of 45 squared plus 19.5 squared. Now this is equal to, if we take all the values in the calculator, it should be 49.04334817 centimeters. Now we found the height of one of our triangular faces. We can now find the area of it by using our equation for the area of a triangle: half times base times height. So we have our height as our value given in our calculator, 49.04. And then we have that multiplied by our base, which is 39 centimeters. So this is for the big triangle, remember, so we take the entire length of the square base. And so if we plug this into our calculator, we get the value for the area as 956.3452894. And since this pyramid has 4 triangular faces, we multiply this value by 4 to give us the surface area on the outside, excluding the base. And this gives us 3,825.381157 centimeters squared. And this is for the 4 triangular sides. Now, the next thing that we're going to try and do is we're going to find the surface area of one of our smaller triangles. So, what we're going to do is we're going to now draw the same triangle and we're going to shrink it down. So now, instead of having a height of 45, we have a height of 15 centimeters, which is 45 divided by 3. Following on in the same pattern, we divide our base length also by a scale factor of 3. So previously we'd have seen that the base was 19.5 centimeters. This will now be 6.5 centimeters, which is 19.5 divided by 3. Now we could use Pythagoras to find our hypotenuse once again, but since our triangles are similar, a hypotenuse can also be divided by a scale factor of 3. And our value for the hypotenuse that we have seen was 49.043 ... And so we can divide this by 3 to get the length of the hypotenuse for our smaller triangle. And this hypotenuse is 16.34778272 centimeters. Now, we can once again use our formula for the area of a triangle, half times base times height, and we can substitute our values in. And so, for our base value, since 45 divided by 3 is 15, our length value for our square, our 39 centimeters, can be also divided by 3. And 39 divided by 3 gives us 13. And so our base here for our smaller pyramid that's getting cut off, base length is 13 centimeters. We have our height as 16.347, so on. And so if we plug this into our calculator, we get our area as 106.2605877 centimeters squared. Now, what we want to do is we want to find the surface area of all 4 of them together. So we're going to multiply our value by 4. So the area of one of our smaller triangles here was 106.2605877. We're going to multiply it by 4 because there are 4 triangular faces, and so we're going to have our answer as 424.0423508 centimeters squared. Now, from this, we have to subtract this answer here that we have from the surface area that we got before for our 4 large triangles. And this will give us the outside area of our frustum shape here. And so let's do that calculation. So we have 3,825.381157, and from that we subtract 425.0423508, and for that we get our value as 3,400.338806 centimeters squared. Now this is only for the surface area on the outside. What the last thing that we have to find is the surface area of our top and the bottom of our frustum. And so for the bottom and the top, they're both squares. So the length of our base we have 39. We should note that the area of the square would be x squared, where x is the length. And so the area of the base would be 39 squared. And the area of our top will be 13 squared, as explained previously, due to the scale factor of lengths. So the total surface area of our frustum would be the value that we've attained before, our outside value of 3,400.338806 centimeters squared, plus we're going to add our 13 squared from our top area and 39 squared from our base area. And when we add these all together, we get the total surface area of our frustum as 5,090.338806. And in the question, it asked us to the nearest whole number. So the answer that we would write in our exam would be 5,090 centimeters squared. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.